This lesson is 11.5. We're looking for trig functions of any angle in our coordinate plane. So our goal for today is I can find exact values of trig functions for certain reference angles. So our reference angles are going to be our 30 and 60 degrees and 45 degrees. So you can imagine we're going to use our reference triangles of our 30, 60, 90 and our 45, 45, 90 triangles. When we say exact values, we are looking for things with square roots in them. We're not looking for the repeating decimal. So these are going to be non-calculator, so we are not going to be using our calculator for these. We're going to be using our knowledge of our reference triangles in order to find these exact trig functions. So the problems that we're going to be looking at are problems like this, where it says, find the exact ratio for sine of 60 degrees. So sine of 60 degrees is, our goal here is to create this angle in our coordinate plane. So we had practiced this before, so let's draw the angle for 60 degrees. So here is 0 degrees. Here's 90. So I know that 60 is going to be between 0 and 90. It's going to be in quadrant 1. So if I draw this angle, this is 60 degrees from here to here, which is nice when we're in the first quadrant because 60 degrees is our reference angle, the angle that's closest to the origin and on our x-axis, and creates that angle with our x-axis. So we know our reference angle here is 60 degrees. So we want to find the sine of 60 degrees. So we draw our angle, find our reference angle, and now we want to create our triangle. So if I draw a triangle, we imagine that straight. This would be our right angle. So we can now find all the sides of this triangle because we know that that's 60 degrees, that's 90, therefore our other angle has to be 30. It's a 30, 60, 90 degree triangle. Across from 60 is always root 3. Across from 30 is always going to be 1. And across from 90, our hypotenuse is always going to be 2. So we can now use this to find sine of 60. Well, we know that sine is opposite over hypotenuse. So the sine of 60 degrees is going to be opposite of this angle. So opposite is root 3 over hypotenuse, which is 2. So our exact value of sine of 60 is root 3 over 2. And it's positive because we're in the first quadrant. So let's look at example 2. This says find the exact ratio of tangent of 135. So our first step is let's draw the angle 135. So I have 0, I have 90, I have 180. So now I know that 135 is going to fall between 90 and 180. So it's going to be in quadrant 2 here. So I'm going to draw that. So this angle here is 135. However, when I want to find my trig functions, I need to create a triangle. And to create a triangle, I draw straight down. I need to find my reference angle here. Remember, my reference angle is always the angle closest to my x-axis. So essentially what I'm trying to figure out is if this is 135, how far away is 135 from my x-axis, 180? So to find my reference angle, 180 minus 135 gives me 45 degrees. So this angle here, my reference angle, is 45 degrees. Well, I can figure out my trig values based on this angle because I know across from 45 is 1. Across from our other 45 degree angle is 1, but we need to be careful because while it is 1, if we're working in our coordinate plane, it's actually -1 because our values on the left side of our y-axis are negative. So this is -1 and our hypotenuse is always positive, and it's +2. So to find tangent of 135, we know tangent, if we think of SOHCAHTOA, is opposite over adjacent. So if we find the tangent of 135, it equals opposite over adjacent. So our answer is -1. So we need to make sure that we're paying attention to our positive and negative values as well when we make our reference triangles, depending on what quadrant we're in. Also, we didn't use it, but that 2 should actually be square root 2 if we're talking about a 45-45-90 triangle. All right, so we've done an example in the first and second quadrant. So how about you guys go ahead and try this one. Find the exact ratio for cosine of 150 degrees. So draw your angle, find your reference angle and draw your triangle, label your triangle, and then find cosine of 150. Then go ahead and play the video to check your answer. All right, so hopefully you tried this one out. So if we draw 150, it's going to be between 90 and 180, so it's going to be in quadrant 2. And if we find our reference angle, it's 30 degrees, so across from 30 is 1, hypotenuse is 2, and our side across from 60 is root 3, but it's going to be negative in quadrant 2. So if we want to go ahead and find cosine of 150, we know that cosine is going to be adjacent over hypotenuse. So according to our reference angle, this is adjacent, this is our hypotenuse, so it's going to be negative square root of 3 over 2. All right, so example 4, find the exact ratio for tangent of 240 degrees. So we're moving along in our coordinate plane here, and we have 0, we have 90, we have 180, but we are above 180 here, and our next quadrantal is at 270 degrees. So we are actually going to be in quadrant 3 for this problem. So if my angle goes around from 0, past 90, past 180, it's going to be over here between 180 and 270. So here's my angle of 240 degrees. So I went all the way from 0 to 240. Now I want to draw my reference triangle. So that's going to go up to my x-axis. And I need to find my reference angle, how far away I am from my x-axis. So I'm at 240. I want to know how far away I am from 180. So 240 minus 180 gives me my reference angle, and that's going to be 60 degrees. So I'm going to use my 30, 60, 90 triangle. I know that across from 60 is root 3. Across from 30 is 1, and across from 90, my hypotenuse is 2. Now I need to pay attention to my negatives. I went to the left, so it's -1, and I went down, so it's negative root 3. So big thing in quadrant 3, make sure we pay attention to those negatives. So if I want to find the tangent of 240, we said that tangent is opposite over adjacent. So if I'm using this angle, my reference angle closest to the origin, opposite over adjacent. So I have negative root 3 over -1. So fully simplified, 2 negatives is going to give me a positive square root of 3. So the tangent of 240 is positive root 3. In our last example here, find the exact ratio for sine of 315. So why don't you go ahead and copy down the coordinate plane, draw 315, draw your reference triangle, find your reference angle, label it all, and try and find sine of 315. Play the video to find out if you have the correct answer. All right, so I'm drawing the angle 315. So I start at 0, go past 90, past 180, past 270. So I'm between 270 and 360 in quadrant 4. So here's 315. So I drew in this angle. I drew my triangle with my x-axis. And I found my reference angle. So how far away is 315 from my axis, from 360? So 360 minus 315 tells me that my reference angle is 45. So I have 1, 1, root 2, but since I'm going down here, it's -1. So if I want to find the sine of 315, sine is opposite over hypotenuse. So based on my reference angle, this is opposite, this is hypotenuse. So I have -1 over the square root of 2. Well, we know we can't have a square root in the denominator, so we got to rationalize by multiplying by square root of 2 in the numerator and denominator. So -1 times square root of 2 is negative square root of 2, and square root of 2 over square root of 2 is, or square root of 2 times square root of 2 is 2. So sine of 315 is negative square root of 2 over 2. So the last bit of information here is you can always draw your triangles and determine what is positive and negative based on where it is in our coordinate plane. But we should know that there are certain trig functions that are positive and negative depending on what quadrant they're in. So here we have quadrant 1, here we have quadrant 2, here we have quadrant 3, and here we have quadrant 4. Now, the reason that our reference triangles are 1, square root of 3, 2, is because they're the lowest values. They come from what we call a unit circle. And our unit circle just means it's the circle in the coordinate plane with a radius of 1. So we use a radius of 1 to build these triangles, so it's in its lowest terms. So if we were to have a circle, all of these angles are on this circle, meaning that each one of these is a coordinate on our coordinate plane. So if you were to find a coordinate, it's always cosine sine. So if I have a unit circle, every point on here is cosine sine, x, y. And then you can see you build your triangle, and that's where all the points on this unit circle come from. Now, we know that in each quadrant, some x values are positive, some are negative. So what I'm getting at here is that in quadrant 1, everything's positive because your x values are positive, your y values are positive. So everything here is going, all trig functions are going to be positive. If we look at quadrant 2, here our x values are negative, but our y values are positive. So that means all of our sine functions are positive, but cosine and tangent are going to be negative because our x values are negative. In quadrant 3, tangent is going to be the only thing that's going to be positive because both x and y are negative, and if we have two negatives, they make a positive. And then in quadrant 4, cosine is going to be the only thing that's going to be positive because X is positive, Y is negative. So that means sine values are negative, tangent values will be negative, but cosine is positive. So it's kind of a nice trick to help you see if you have it correct or not. And one way you can remember it is all students take calculus. So if you remember that, you know which trig functions should be positive. In quadrant 1, all. In quadrant 2, sine. In quadrant 3, tangent. And in quadrant 4, cosine. So all students take calculus. If you go in that order, those are the only things that are positive in those quadrants. So if I drew it out, everything, all students take calculus. All trig functions are positive. Sine is positive, tangent is positive, and cosine is positive. So just a nice little trick to make sure that you're looking at your trig functions and making sure which ones are positive and which ones are negative in your final answer.